Hi guys, in this session I would like to discuss about magnetism and matter. We know that magnetism is a universal phenomenon. So first we will observe earth magnetism, and in the previous concept we learned about how this earth magnetic field will protect us from solar radiation. That also causes a beautiful natural phenomena, aurora borealis, at the poles. Earth is having a very big giant bar magnet inside it, and this magnetism itself is a universal phenomenon. So if we can move anywhere in the universe, the planets or stars, even the galaxies, they all exhibit same natural phenomena. Let us give a quick guess. Other than Earth, which are the planets having natural magnetism? Other than Earth, which planets? So if we can do some research, the Mercury is also having its own magnetic field, but not much stronger. But the reason for its magnetic field is different for different planets. First, let us guess about what is the reason for Earth magnetic field. So we know that inside Earth, what is the structure? The Earth is having a molten iron in the liquid form. That's known as molten iron. So iron is having so many electrons, and in our previous concept we learned about that electron, a moving electron, is responsible for magnetic field. So that could be the reason, the molten iron, the liquid iron, which is at liquid state at the higher temperatures, because Earth itself is having one more sun which is inside. That high temperature causes iron metal in the form of liquid, so that electrons movement, they are in random motion, that causes magnetic field. That is one of the theory. So likely different planets, they do have its own magnetic nature. The Mercury, it's not much stronger. Its magnetic field is due to because of rotation, and Jupiter much stronger than any other planet. So Jupiter magnetic field is much stronger among all solar planets because it's 70% filled with liquid metallic hydrogen. And Saturn, same as like Jupiter, and also due to its fast rotation. And what about the Uranus and Neptune? So guessing that due to its ionic ocean, they do too have its own magnetic field. So when it comes to Earth magnetic field, so we know about the story of the Earth magnetism. So how it's evaluated with the human. The word magnet is derived from the name of an island in Greece called Magnesia, and where the magnetic ore deposits were found. And we know the tale that shepherds on this island compelled that their wooden shoes at the time stay stuck to the ground, because their wooden shoes is the iron chip rods, they are affected. So this attractive property of magnets made it difficult for them to walk around in the magnetic rocks. Not only that, in the human evolution, so these magnets started to use a thin long piece of magnet, so that if suspended, that it shows north and south directions. And by using that, Chinese in the early around 400 BC So they started to use the magnetic needle as a compass for their travel purpose, and that gives a huge revolution. And after that, some in the battlefields also, this technique is very useful to predict the location or to make a good tactics in the wars. Just to go through some matter is given in the concerned textbook in the introduction part. So that is the historical about how this magnetic evolution is taken place with the humans. So other than the planets, if we guess, what about sun? If it has so stronger, then what are its effects? And we learned that in our previous concepts, sun is also to exhibit its own magnetic field because of its solar flares. We can guess the result. What could be the reason? The reason, sun is also having a liquid hydrogen, and those electrons are in liquid state. Those causes currents. A charge particle, it creates magnetic field. Yes, the stuff goes like that. So it also exhibits a strong magnetism. A very interesting point regarding the sun magnetic field. So for every 11 years during the solar cycle, the poles of the magnetic of the sun gets flipped. So according to study, the sun magnetic poles, it will be flipped for every 11 years. So this is some curious point here. So like that, the earth poles also will flip for every 10 power 4 to 10 power 6 years. Now at present, what is the earth magnetic poles? Where is the north pole and where is south pole? And that is flips. But our time period is too long. It's about 10 power 4 to 10 power 6 years. So this is a natural phenomena in every one of our lives. It should take place. Life is like cyclic. Sometimes we can up and sometimes we will be down. But we have to move on with the time. So when right situation comes, we will be go up and again we will come down. So that is the life it means. Okay, come back. So let's study about the earth magnetism. So the earth magnetism, it behaves like a magnet with a magnetic field, which is placing a bar magnet which is inside it, just like north pole and south pole. The earth behaves as a magnet with the magnetic field pointing approximately from the geographic south to geographic north. So the magnetic field line direction, that is also you can notice it here. Not only that, the geographic north pole is actually a magnetic south pole and it attracts north pole of compass. So here I want to reveal a very important point at here. Suppose if you hold a compass, we know that compass needle itself a magnetic material. So that's the reason compass needle is showing towards north direction. We know the magnetism having the attractive and repulsive property. Like poles repel each other and unlike poles attract each other in magnetism. Suppose in my hand, if I place compass in my hand, my compass needle is showing towards north. It's showing towards north. It means there is attraction force between the compass needle north pole and earth south pole. Yeah, that's the reason the compass needle is showing towards north direction. So a magnetic north pole is actually, sorry, a geomagnetic north pole is actually a magnetic south pole. It attracts the north pole of compass. I hope you got it, that point. Again, I can repeat it here. The geographic magnetic north pole is actually magnetic south pole. If you can compare the directions at here, or later in class I can in detail elaborate that point. Now apart of that, if we can go ahead, when we can suspend a bar magnet, just you hang a bar magnet in the earth magnetic field. So usually the bar magnets aligns in terms of north to south direction. Yeah, if you can just tie up a bar magnet and just hang it. So the bar magnets always aligns in terms of north to south direction. But the tip which points to the geographic north is called north pole. And the tip which points the geographic south is called south pole of the magnet. So if a bar magnet is aligned in terms of north to south direction, now what does that mean is the tip which points to the geographic north is called north pole of the tip, and the points to the geographic south is called the south pole of the magnet. And apart of that, we know that repulsive force between north poles and two magnets about each other. So conversely, there is an attractive force between north pole of the magnet and the south pole of the magnet. So like poles repel each other and unlike poles attract each other. And very important point at here, there is no isolate the north or south pole of a magnet. It means if you break a bar magnet into several pieces and each piece will act again a magnet. So just like if we can compare an electric and at here electric fields or electric charges. Yeah, electric charges. In electric charges we have isolated charges, isolated positive charge, isolated negative charge. But when it comes to magnetism, so that facility we won't get it at here. Means still now there is no evidence of existing of magnetic monopoles. Till now there is no existence of magnetic monopoles. It means no magnetic mono north pole or magnetic mono south pole do exist. So magnetic monopoles do not exist. And not only that, as a natural magnets, if you can talk, magnets can prepare. It's possible to make magnets out of iron and some alloys. So just if you can rub with that iron on a natural magnet, so that material gets magnetized. And we will learn in this chapter about certain magnetic materials which are the more in favor of magnetism, like ferromagnetic materials. So that gives much more elaborate how this magnetic field affects the material. And think a point at here, without this magnetic materials and magnetic property, nowadays the present technology will not be successful. Now whatever we want, we are just YouTubing and searching. So how many YouTube videos are uploading per minute? You can just imagine. And those videos are where they are storing. When storage comes, everything related to magnetic materials. The phone which is present in your hand having roughly 64 GB of its capacity. When it comes to higher capacity, 1 terabyte and above that and all. So even though the size is small, but how the memory is capable of increasing? Who is that memory storage device material? If you can dig that question, you will get interesting points regarding that magnetic materials. Yeah, in the course of time we will go through about that and all. So this is all about the earth magnetism. So apart of that, if you can take a bar magnet, we know the basic bar magnet. Bar magnet do comes in North Pole and South Pole. So here what the lines which are drawn, if you closely observe it here, so these lines are known as magnetic field lines. Magnetic field lines. Let me give evidence how these magnetic field lines do form. Suppose if you have iron filings, you know that iron powder. Just take a iron rod and grind it and bring a powder that becomes iron filings. If that iron filings just sprinkle on a natural magnet, so they do form, they do align. So that alignment tells about the magnetic field lines. So the magnetic field lines here appears to start from north and ends at south. Magnetic field line starts from North Pole and ends at the South Pole. Not only that, the magnetic field lines do adhere, they do form closed loops. Here you can see, they do form closed loops. And inside, if you can see that the magnetic field lines are passing from south to north, and according to the number of field lines are more, there is the magnetic field strength is also more. Let us get a visual proof how this magnetic field lines form. So this is the one of the YouTuber. So he is making the same presentation of magnetic field lines. So here you can concentrate, this is an iron bar, just like what we see in regular. So he is grinding that one end of the iron bar. Now here you can see some iron filings, iron powder as a word you can use there. So that is deposited, and if you can collect that powder, so he is using a magnet to collect that powder, so that becomes iron filings. So he collected such a good amount to show the magnetic field line patterns. So after grinding that iron rod, just give a quick wash. It's a very so fine powder. Better to give a quick wash of this iron powder. Yeah, ions do not melt in the water, but rest of the dust gets clear, and we can get a clear visualization of the field lines. Yeah, wow, it's very beautiful. So if you can see at here, if this is a North Pole and this is South Pole, the iron which is attracting at here, so it means these two magnets wants to attract. So whatever the magnetic field present in between them, so that field magnetizes the magnetic material which is present in between them. So if this is North Pole and South Pole, the magnetic field lines, they are just like the spikes, the closed spikes here. You can observe that they are the beautiful to watch, very fine. So they forms because the two strong natural magnets form a good natural magnetic field, a strong magnetic field here. And if you can take it out, yeah, there is no magnetic field. Now there is no attraction between that. Now if you can take again the same, the magnetic North Pole to South Pole gets attracts. When it comes to repulsion, so in the repulsion here you can see very carefully. So let it take, if I take this as north pole, this is also north pole. So they do repel each other. Means what is the magnetic material present at here? It wants to attract to this magnet and this wants to attract this magnet. So here you can see there is a nil, means zero magnetic field. So the magnetic field lines, if I draw magnetic field lines, so they do form like that. So they do form like that, and here also they do form like that, magnetic field lines. So we will draw certain magnetic field lines patterns, not like this, but this is a visual proof that magnetic field lines will exist. Suppose if we take a circular magnet, a circular magnet, it means at the center the magnetic field equal to 0, and if you take a bar magnet, this is an equivalent to bar magnet. And here I want to say one point. Suppose this you take a north pole and south pole, the strength of the magnetic field lines at the poles equal to maximum. Not only that, if you can observe very closely like this, it is going to form just a small like that. It's having a very good nice pattern. So his ideas are very good to represent the magnetic field lines. It's a very visual, beautiful visualization of the magnetic field. So he's playing with that. So but I got a very curious at here. So if you can see at here at the center, if this is a north pole and this is south pole, so the magnetic field lines here, they do form like that. So that's the reason here at the center the magnetic material is caught. It is suspended in the water because the strong magnetic field is holding it without falling against the gravity. So I hope you got a little experimental evidence or magnetic field lines about that, a realistic experience of the magnetic field lines. So this is the magnetic field line patterns which a bar magnet can show. So if we can do a comparative study between electric field and magnetic field. So this is a very important point, you need to get it. So electric field, because of the two charges, positive charge and negative charge, or because of two mono charges, if I exclusively say two mono charges, the positive charge electric field lines and the negative charge electric field lines. And not only that, if we can keep two charges at a distance, it forms a dipole, or two opposite charges also it forms a dipole, and we draw the electric field line patterns very beautifully we draw, and we know how to represent of that representation. But one very key point at here, electric field lines, they do not form closed loops. So that is one of the important point in the electric field lines. But when it comes to magnetic field lines, they do form closed loops. And magnetic field lines appears to start from north pole and they appears to close at the south pole. And inside the magnet, they travel from south to north and they do form closed loop. And if we can place a compass in the magnetic field line, so it shows in magnetic north direction. So let us do a comparative study between the electric field lines and magnetic field lines. So this field lines concept is very helpful to us to visualize what is realistic thing happens with the charges and with the magnetism. So, and that diagrams also will be gives a very useful visual representation what we think abstractly about the field and this and that, but it's good to have that knowledge, electric field lines and the magnetic field lines, and that is also very proper knowledge. So other than the magnet, natural magnets, so how do we create a magnetic field? So this concept we learned in the previous chapter. So that is a current carrying conductor is a source of a magnetic field. A current carrying conductor is a source of a magnetic field. So we studied about solenoid, toroid and all, and here if I can do a comparative study at here, a bar magnet is equivalent to a current carrying solenoid. So how magnetic field lines in a current carrying solenoid forms that is equivalent to a bar magnet. So we studied much about the magnetic strength of a bar magnet be equal to mu naught Ni. N becomes number of turns, I is strength of the current, mu naught is permeability. And the direction, we used right hand thumb rule. The curl of fingers represents the direction of magnetic field. And right now at here we need to study about little deeper about bar magnet. So let's see something about bar magnet, very basic things. As I said in the earlier, if you suspend a bar magnet, it always aligns north to south direction, and if we can place iron filings will be accumulate more at the poles, because at the poles the magnetic field strength is strong. A suspended magnet, so it means it shows north direction, it means north pole of bar magnet shows geographic north direction, and the strength of the magnet is concentrated at the ends, which are called north and south poles. And when it comes to attraction and repulsion, so magnetic forces like poles repel each other and unlike poles attracting each other. It means north to north they repel each other, and north to south they will attract each other. So we can describe magnetic field lines by imagining a tiny compass, very small tiny compass which is placed nearby the points. So how to draw magnetic field lines if we don't have that iron filings in our hand? Suppose if we run a compass in the vicinity of the magnet, so the compass needle, the direction of the magnetic field at any point in the same direction which is indicated by the compass needle north pole. So if we run a compass on this line, so always the direction of the needle changes. It will give that evidence. And the magnetic field is more strong, so that is also we can identify at here by seeing that number of magnetic field lines. So the number of magnetic field lines are more at the poles, and even though they are close at here, but they do not intersect. So that is a very key point at here when we discuss about the magnetic field lines. So the magnetic field lines, they never interact each other, even though they do form closed loops and the strength is more, but they never interact each other. Now between the like poles and between the unlike poles, so the magnetic field lines appears to start from north and ends at the south. It means when you place two like poles, so they do attract each other. Why? Because north pole magnetic field lines wants to enter into the south pole of another magnet. So that's the attraction of that ones. So this is the magnetic field line patterns between magnets. And when we bring two like poles, so they do repel each other. So because from the north pole the magnetic field lines leave, so they are finding where is that south pole, then only they can enter to the south pole. So at here between the magnetic field, there is between these two like poles there is no magnetic field because of the repulsion. So these imaginary lines which represent the direction of magnetic field is known as magnetic lines of force. or simply magnetic field lines. And when it comes to property, the imaginary path traced by an isolated unit north pole is defined as line of force. Here unit north pole we don't have, so that's the reason in the compass needle, the small needle. Think about it here, what the compass needle having? First of all, the compass needle itself is a magnetic material. The compass needle which is made up of, that's a magnetic material. A magnetic material only attract another magnetic material. So that's the reason the compass needle north wants to attract. So that's the reason it always shows the north direction. The compass needle of north wants to attract the south pole of the earth. So that's the reason it always wants to move that direction. So here the compass needle itself is a magnetic material. So that's the reason it only shows north and south direction. So when it comes to its properties, as per I said, the magnetic field lines force are from closed loops. Outside the magnet, the direction is from north to south, but when it comes to inside the magnet, this is from south to north pole. And they never have any origin nor end. They do form, they do appear like that, but when it comes to reality, they never have origin or end, infinity. The magnetic field lines do not interact, because if they do interact, then at that point the direction of magnetic field is shows at two possible situations. Think here a case, how to find the direction of magnetic field for a given magnetic field lines. I think you know how to find that. Yeah, just we need to draw a tangent. The tangent of that curve represents the direction of the magnetic field. So if two lines are interacting each other, then at that intersection point, if you can draw tangent, it shows two different directions. So that comes to impossible. Now the tangent drawn at any point on the magnetic field line, that indicates the direction of the magnetic field at that point. Or if you have the help of compass, bring a compass and place that one. The compass will be help us is to it draws a tangent at that particular point to show the direction of the magnetic field, or just draw a tangent at that particular point, then it can show the direction of the magnetic field. At the poles of the magnetic field is stronger, much stronger, because you can see at here at the poles the magnetic field lines, or if I can use the word magnetic field density, is high at the poles. And here I can throw one more definition at here. The number of magnetic lines of force passing through unit normal area is defined as magnetic induction. So this is all about the earth magnetic field, and when it comes to a bar magnet. But we need to study a little deep inside about the bar magnet. We do not touch any kind of the mathematical equations or nothing we did. Just we studied about only the magnetic field lines. So in my next concept, I would like to give an evidence how a bar magnet as an equivalent to a solenoid. So we got it that from a solenoid is an equivalent to a bar magnet. Let's see one more time how this bar magnet will be an equivalent as solenoid. That's we can discuss in the next class.